Good afternoon, everybody. Welcome to Tibbetts Physics. What is crappinin'? Today, we are going to create a conceptual map and talk about study tips for our first units. We're going to organize our thoughts off the top of our head first, and then what we're going to do is see what we remembered, and then we'll use our standard sheet to fill in any blanks of things we've forgotten over time. So a conceptual map is just a map that's going to help us organize our ideas, and we'll go from there. So the first thing we talked about throughout this unit, we'll call it the basics. And these basics included scientific notation, we also had unit conversions, and we could throw in there order of magnitude. If you're in my Regents Physics class, you could use this for your journal entry for your review for the unit, or hopefully if you're not in the class, you'll find this just as useful. So scientific notation, let's go into the details of what we did for scientific notation. We had two ways of writing scientific notation. The first was for numbers that were greater than 1, and we counted from the right to the left, our decimal places. So counting places right to left, and when we wrote our exponent to the power of 10, our number was a positive exponent. And then the opposite for numbers that were less than 1, so between 0 and 1. We counted from the left to the right. And our exponent, the power of 10, was a negative exponent. If I were you, if this were something that you struggled with, then I would do an example of each one beyond here. For the sake of time, I'm going to skip that. Okay, for unit conversions, the next one, we should remember that the number 1 was always attached to the prefix. So 1 kilo, 1 milli, 1 centi, 1 tera. And then the other number, something that was 1 times 10 to the whatever, we'll call it n. So whatever you're converting, that was attached to the base unit. So 1 times 10 to the blank meters, grams, whatever. And what we did with these was we set up a proportion to convert our units. So next thing was make a proportion. Again, if this were something that you thought was difficult, I would come up with an example problem and do it right here. And the last thing for the basics was the order of magnitude. And I know this is a simplified version, but we're just going to say is the number above the 10. And we'll leave a little space for you to do an example. All right, the next thing we could talk about are how we made measurements. Here we've got accuracy of numbers, precision, and sig figs, but we'll add that to precision. So accuracy is how close you are to the actual value or the desired results. I'm just going to write how close. Precision is how often. So how often did you get similar results? How often did you hopefully get right results? Or sometimes how often did you get wrong results? If you frequently got wrong results, you'll want to do it again and fix your experiment. Okay, for precision, we'll do this in a different color. We have sig figs. And sig figs are a degree of precision. It looks like we're running out of a little space here. Hopefully you've got some more room up top. For the sake of time, I'm going to skip this, but we have counting sig figs. If we have no decimal place, if we have a decimal place, if we're adding or subtracting, multiplying and dividing. So if you want to add those, feel free. Okay, the next topic. Couple more. Vectors and scalars. We'll make two separate ones for those. Vectors and scalars. Vectors are magnitude and direction. So magnitude and direction. Let me put that underneath. Sorry. Magnitude and direction. A scalar is just magnitude. So far we've learned a few vectors and scalars. We could add those to it if we'd like. We've learned that velocity is a vector. And acceleration is a vector. As well as displacement. For scalars, we've learned that the opposites of velocity, acceleration, displacement, actually velocity, acceleration, speed, running out of room here, speed, and distance. Okay, so if you had space, what I would do if I were you is I would add to the definition of velocity, definition of acceleration, displacement, speed, and distance. And we're going to make one more line way out here. Sorry about that. And we're going to call this motion, the most recent thing we talked about. And we have two types of motion. We have constant velocity or constant speed. Oops. We'll draw a circle. And we also have accelerated motion. This afternoon's tea is chamomile. I'm hoping it'll give me a boost of energy. Okay, so for constant motion, we have velocity. Average velocity is the change in distance over the change in time. We also made motion graphs of distance versus time, and we said that the slope of the motion graph, oops, I should make that orange still. We said that the slope of the distance versus time graph, so y-axis is distance, x-axis is time, the slope is the velocity. And we also talked about how to find the total distance and how to find the total displacement. So you might want to add a branch there and there for total distance, total displacement. Acceleration, we learned, has a whole bunch of formulas from one of the videos we watched. The most basic one is acceleration is change in velocity over change in time. Because acceleration is a vector, it has both magnitude and direction. So for an object to accelerate, you could add here, increase in speed, decrease in speed, change in direction. And then we have all the other formulas that you watched. Vf equals Vi plus At. which is similar to the one in pink. Oops, don't want to do blue again. VF squared equals VI squared plus 2AD. And then the last one, nope, we'll skip green, dark blue. D equals VIT plus 1/2 AT squared. And these are used based on the information you're given for that specific problem. From the acceleration equals change in velocity over change in time, we have the velocity versus time graph. So you could say V versus T plot. And we learned that the slope is the acceleration. And the distance is the area under the curve. Area under curve. Okay, now I've been teaching this class for the past 30 years, assuming you're watching this in 2046. 36 actually. So I think I have all these ideas memorized from the first unit. But if I were you, for the next test, or this one, is you want to look at your standard sheet. Did we talk about converting units using ratios, scientific notation? I didn't talk about solving for unknowns, so if you need some extra help in algebra, you might want to add that there. Distance versus time, velocity versus time, we talked about. Vectors and scalars conceptually. Mathematically, so that's like the difference between distance and displacement, or speed and velocity. We didn't look up setting up vector diagrams and solving for the resultant, or on a coordinate plane. And we did not talk about what affects the period of a pendulum. Alright, so now that we have the conceptual map created, what we want to do is figure out how do we study these specific topics. I could label them, and I could write little notes about each one, but how do I practice to make sure that when I enter this test, that I don't have to think about these problems while performing it, and I could just do. So what you want to do, probably like the week before the test, so if you have a Friday test starting on Monday, you'd want to make this conceptual map. And then you want to pick a couple of standards, maybe 2 to 4 standards per day to start reviewing. The best way to review is to self-quiz yourself. So I look at the first standard, convert units using ratios. What I would do is I would just make up an example and try it out. So I would just say, okay, let's do 732 centimeters to meters. And I would try it out without looking at my notes. Then once I get the answer, I'll go through my notes or an old quiz to see if I follow the correct process, or maybe even ask my teacher the next day. So what you want to do, again, is you want to self-quiz yourself on 2 to 4 standards a day. So for the first day, what I would do, hopefully this works. The first day, I would look through the basic ones, the first 3 standards. Can I convert units using ratios, write scientific notation, solve for unknowns? Now, since this may be your first time studying for a physics quiz, and you're not comfortable with making your own questions, what I would do is I would look at your old quizzes or homework assignments. So the first one was convert or write scientific notation. So here's a quiz. Cover up the answer that you had from the first quiz. Hopefully you made correct feedback. And then answer it on a blank sheet of paper. And then you could compare the process. Same thing with converting units. Cover up the answer. Write it out on a separate sheet. And then compare yours to your new one to the old one. So then on day 2, so this would be Tuesday, I would then add more standards. So I'm still going to do the first 3, and I will add some more. Now these standards aren't in order from what we learned, so let's figure that, or fix that. The next thing we did were vectors and scalars conceptually and vector diagrams. So I'll do the first 3 and the next 4 on day 2. And then day 3, we looked at motion graphs. So I would do, later in the unit, we looked at motion graphs. So then I would do the first 3 standards, the 4 standards about vectors and scalars, velocity versus time graphs, and you might as well add velocity and acceleration problems. These 2, the last 2, describe what affects period of pendulum, order of magnitude. Those are something that you should just remember. Hopefully you could remember those from the lab. If not, I would add those to the first day. Sorry about that. And then finally, the day before the quiz, you don't want to cram. What you want to do is you now want to self-quiz yourself. Again, look at old quizzes or homeworks if necessary, but do the review backwards. So start with what's most fresh in your head first, and work your way back up to the beginning of the units. You'll find that by following this method of studying that your long-term memory will actually improve versus just cramming the night before and remembering the material for the test, and then you'll just forget it the day after. But through this method, you'll remember it long-term, so when it comes to quarterly exams, midterms, or final exams, it'll be much easier to recall this information. So when it comes to the tests, when you're taking your Regents exam, you'll be able to hit them with the hein and do really well on it without actually having to think too hard, because it'll be in the back of your memory. If you found this video useful, please like and subscribe. See ya!